maybe I'm wrong about this, but I feel like principal values and the topic of principal values is sort of one of the dreaded topics in math analysis and in trigonometry. And in order to get around that, I really want to try and talk about what principal values are in a simpler sense before we get into the trig. So the first thing I want us to remember is that the thing that defines what a function is that if you input a number into a function, you will get back one, or I mean maybe no outputs, right? You're going to get one thing back from a function. If that requirement's not met, you don't have a function. Instead, what you have is called a relation, right? And that's a problem. Like math, lots of times we want to have functions around. So much of what we do is based on functions, right? When someone asks you for the principal value of a relation, they're basically asking you for what the primary answer is. Principal values basically recognizes, hey, I've got a quote-unquote function here that has many answers, but I want you to only choose one. So the principal value is basically the way of saying mathematically, okay, fine, you've got multiple answers. What's the best answer that you have? In my opinion, one place that you guys have already seen principal values is actually in square roots. For instance, if I were to ask you, what's the square root of 9? Right? In some sense, we know the answer is 3. But some of you would say, well, it's actually plus or minus 3. But if you think about that for a second, that means that square root isn't a function. Because, imagine if I said, the f of x function is the square root of x. And then someone said, what's f of 9? And they went and tried to say, it's plus or minus 3. What I'm saying here, strictly speaking, isn't quite correct, but I hope you're seeing that there's an issue here, right? This isn't a function, because when I plug 9 into the square root, it's trying to give me back two things, right? And so effectively what we find is that with the square root function, the principal value of the square root function is the positive number. So, if we extend that a little bit further, so then suppose someone were to ask you, what's the square root of negative 25? Well, we know that the square root of negative 25 is supposed to be 5i, which I guess means plus or minus 5i. And so what that means is you've got, positive 5i as one of the square roots of 25. You've got negative 5i as the other square root of negative 25. But the principal value is this one. In other words, if for some reason someone wants you to only give one answer back, you're going to use the principal value, and that's going to be this one. I feel like I can't resist making one other sort of strange statement. What about the fourth root? Like, for instance, the fourth root of 1. I don't know if you guys know this, but if not, then this is just kind of a fun bonus. The fourth root of 1, because it's a fourth root, actually has 4 answers. The fourth root of 1 could be 4, could be 1, or negative 1, or I, or negative I. And if you don't believe me on that, actually, think about taking each one of these things and raising it to the 4th power. You'll find that all of them get you back to 1. It's kind of interesting. So this is an instance where this is really not a function, right? I plugged in 1 and I got back 4 answers for this thing. Of these 4, which is the principal value? Well, we've already mentioned, sort of the positive and most simple one is going to be the principal value. So of these 4 possible answers, this one, positive 1, is the principal value. So we recognize that there are some multi-valued functions, and occasionally we want to give only one answer, and sometimes we want to give lots of answers. The question is, when do we have to care? In other words, when do we give multiple answers, and when do we only give the principal value? And it's actually a fairly simple thing. You use the principal value, so you will give only the one main value when that expression is pre-written in an expression. So what I mean by that is, if you had a problem that asked you to do the square root of 9 plus 5, in other words, the instructions on the problem were simply simplify or evaluate the square root of 9 plus 5. In this problem, they've written the square root of 9. They intend for you to use that value, and so we will simply do 3 plus 5 and get 8. And some people might object, well, don't we want to say negative 3? If they meant negative 3, they would have put a negative sign here. If they wanted plus or minus, they could have put plus or minus there. The reality is when the problem writer here wrote the square root of 9, they wanted you to use only 3. We'll contrast that with if you, in the course of solving an equation, apply one of those functions, you have to give all the possible solutions. So for instance, if I had instead asked you to solve, so we'll solve x minus 5 squared equals 9. Okay. Notice that in this case, there's no square root in the problem. No one has written down, hey, there's a square root and there's a multi-valued function in this problem. In this case, we are going to have to do that. We are going to have to take the square root. And when you take a square root and get x minus 5 equals, here you must supply all possible answers. And the reason is you're sort of saying, like the setup of this problem was that something squared equals 9. So what could that something be? Well, there are lots of possible things it could be. In this case, we are solving and looking for all possible values where this could happen. So I need to indicate all possible values where it could happen, right? So once I have that, I have to finish this out. X equals plus or minus 3 plus 5. And so from there, we can actually get both answers. We can end up getting that x is 8 or that x is 2. So in this case, we end up with both answers, whereas over here, you weren't really being asked to find all values. I was simply saying, simplify the expression. Use the value that's already been given to you and evaluate the thing. So the next thing I need to do is I need to talk about how this applies to trig functions, and I'm going to get to that in the next video. So I'll see you there.